Hello friends, welcome back to the lecture number 3 on concrete mix design. In this lecture, I am going to discuss about statistical quality control, quality measurement in concrete construction, and non-destructive testing of concrete. First, statistical quality control. See, concrete have certain amount of variability, means variation in both material and construction methods. Means what? Suppose at two different sites, two different persons are going to cast M20 grade of concrete. So there may be variations in strength, okay, because of difference in material and construction methods. So what we should do? We cannot do large number of destructive tests. So we have to have some quality control. What is the purpose of quality control? To have limit of variability as much as practicable. Means the variation should be in a certain limit. So we use statistical quality control method, which gives scientific approach to the designer to understand realistic variability and to lay down the design specifications with proper tolerance and to counteract unavoidable variations. The acceptance criteria in this method are based on statistical evaluation of test samples which are taken at a random during work progression. Incorporating proper sampling plan, it is possible to ensure certain quality at a specified risk. Means by proper sampling you may achieve quality. So statistical quality control provides scientific basis of acceptance which is not realistic but also restrictive as required by the design requirements for concrete construction. So statistical quality control, there are some common terminologies. We will see one by one. First one is mean strength. This is the average strength obtained by dividing the sum of strength of all cubes by the number of cubes. Suppose you have casted 3 cubes to check the compressive strength at the age of 28 days. So n will be 3 and their average strength summation is written in summation x. Next is variance. This is the measure of variability or difference between any single observed data from mean strength. Suppose we have taken 3 test results at 28 days of age of concrete specimen of M20 grade. So we get results as 21, 23, 24. So there is a variation between the 3 results and their mean strength. Suppose we add 21, 22, 23 and divide it by 3, their mean strength will be varying with respect to single observed data. That is called as variance. Standard deviation is the root mean square deviation of all results. It is given in the formula shown in this slide, sigma. Okay. In this formula, sigma is nothing but standard deviation, n number of observations, and system number of tests, then particular value of observation, what you have got reading, and x bar is arithmetic mean. Standard deviation increases with increase in variability. Means if there is a more variation, then there will be increase in standard deviation. Last terminology is coefficient of variation. It is an alternative method of expressing the variation of results. Okay, it is alternative method. It is a non-dimensional measure of variation obtained by dividing the standard deviation by arithmetic mean, and is expressed as this equation: V is equal to summation x divided by x bar into 100, where V is the coefficient of variation. Okay, this is about statistical quality control. Next point is quality measurement in concrete construction. So we can go for inspection and testing of materials. We can record it. We check the record. Then workmanship. Okay, inspection on workmanship, if they are mixing it proper or not, how they are transporting it, what is the time of placing, mixing, etc. And quality of construction is checked by inspection. Okay, means we have to have inspection on material, records, workmanship and construction. Means in construction means they are using proper formwork, they are doing proper curing, etc. Also, quality measurement in construction is very important, and if it is not followed, there will be severe circumstances such as not achieving the required compressive strength. Then the structural elements will be having deficiency in strength and other factors. Now there are some non-destructive tests that we can use for concrete. They are called as non-destructive testing, NDT. These are very useful and powerful methods for checking the existing concrete structures with respect to strength and durability. Apart from this, in some cases, NDT tests are used for investigation of crack depth and micro cracks. Also, progressive deterioration can also be studied by NDT method. Progressive deterioration means how much your structure is deteriorated from its construction time. Again, these tests are very simple to perform, but at the same time, their analysis and interpretation of test results are not easy, because you cannot perform the test and get the result. Okay, you will get results in some other forms. You have to correlate it with certain equations, certain formulas, certain graphs, and then you will get the strength and durability. We will see that these test methods attempt to measure some other properties, like I said, which is an estimate of strength, durability and elastic parameters. Now which test or which properties? The properties like hardness, resistance to penetration of projectiles, rebound hammer, resonant frequency and ability to allow ultrasonic pulse velocity. Means by performing these tests to check these properties, we will get some results, and that results we have to correlate with certain graphs, equations, so that we can get strain, durability and elastic parameters. IS code suggests that the accuracy of this method is determined by the degree of correlation between strength and the physical quality measured by these non-destructive tests. We will see in short different types of non-destructive test. First is surface hardness test. It is a indentation type. Okay, Pistol William and hammer testing. Actually, he invented this estimation of concrete strength. This test is used for estimation of concrete strength. Rebound test, rebound hammer test. Many of you have seen this rebound hammer. Elastic rebound of concrete. This property is used in this method or test, and you get estimation of concrete strength. There is a graph by which you can get the concrete strength of a particular structure without destructing or without disrupting the structure. Next is penetration and pull-out techniques. In this, use of Simbe hammer, spit pins, Windsor probe and pull-out test. These are used to measure penetration and pull-out resistance of concrete is calculated, and it is then correlated with the concrete strength. Generally, where you cannot have a destructive testing, or if you have to check whether after certain years the concrete is having sufficient strength or not, in that case generally we go for non-destructive testing. Next is dynamic or vibration test. By using resonant frequency and mechanical sonic and ultrasonic pulse velocity methods, we can evaluate durability and uniformity of concrete, and also estimate the strength and elastic properties. Okay, by using ultrasonic pulse or by means of resonant frequency or mechanical sonic methods. Then there are some combined methods, such as you can combine ultrasonic pulse velocity and remote hammer. Next is radioactive and nuclear methods. X-ray and gamma ray penetration tests. Measurement of density and thickness of concrete can be done by using this test. In this test, neutron scattering and neutron activation methods technique is used. Magnetic and electrical methods or electric methods, they determine the cover of reinforcement in concrete. Okay, how much cover is provided, whether it is sufficient or not. And electrical methods, microwave absorption technique used to measure moisture content and thickness of concrete. Okay, how much moisture is present in the concrete, because see, depending upon the cover of concrete, there is an ingress of moisture towards the steel, and you know that for corrosion we require moisture, oxygen. Okay, so without destructing a particular beam or slab or column, we can easily check whether the structure is having sufficient cover or not. Next is acoustic emission technique. This is used to study initiation and growth of cracks in concrete. Okay, how the cracks are initiated, what are the reasons, from where they are initiated, and their growth can be checked by this technique. So that's it from this lecture. These are the references. If you have having any questions, please write down in comment. In next lecture I am going to discuss about the design steps for concrete mix design by using IS code method, that is IS 10262 2009. Thank you very much.